Airborne Motorworks is turning wind energy on its head. They've patented an innovative wind turbine design. Think of a jet engine. This company's wind turbines look very similar. The difference is the use of electromagnetic technology. The low noise and the low profile design allows installation on office tower rooftops or industrial buildings. They say their turbines have a wind energy conversion rate of up to 69.7% of legacy wind turbines. Jesse Marcel, co-founder of Airborne Motorworks, is here to discuss this microgrid technology. Hi, Jesse. Welcome to the podcast.
Thank you very much. Excited
So you're calling in from Washington State?
Yeah, Spokane, Washington.
Great. That's wonderful. So I'm here in Halifax, so welcome to the show. And you reached out to us a couple of weeks ago with really great information about your company, and
Yes.
It's Airborne Motorworks.
Yes.
Tell everybody who's listening who you are and how it all started.
Well, Airborne Motorworks started as a concept for a flying car. Back in the day, it was I and the family driving to Disneyland, and I'm sketching out on a pad, and I got this idea for a car, but realized there wasn't a propulsion system that would work the way I wanted it to. So I ended up by going through learning how to write patents and that kind of thing, drew the whole thing out, and submitted patents and received a patent for the propulsion, and formed a company around it. At that time, it was Airborne Motors, and it became Airborne Motorworks. With it, there's a lot of money involved in propulsion, anything that flies with people on it, and so as we're going along and looking at the money and the time it would take to move that project into basically a flying vehicle, which we're still working on, but it's a very long timeline. And our system, our propulsion, was very, very efficient, incredibly efficient, actually, very powerful and small. And it occurred to me that, we could really, as a propulsion, we could turn it around and run it as a generator. So we started following up on IP and as a generator. And then we started working with to a gentleman named Frank Stanton, introduced us to Maya. And Maya, we met with these folks and went through our designs and all that kind of thing. And then we kind of basically turned our propulsion into a larger system, because our propulsion was small. The generator, the wind turbine that we're going after, was a little bit bigger. And they started going through it. It's like everybody else that works with us. At first, they're scratching their heads going, what are you guys trying to do here? There's lots of wind turbines out there, really big ones. And they happen to be designing, they're one of the designers of those. They and Siemens work together. So they're very familiar with wind turbines. And as they went on and the more tests they do, they realized, you guys really have something here. And it was funny. We're going through, because we're a small, kind of fast moving company. And we, it was more than I would say more than a customer, service relationship. I think we've kind of become friends in a way. And as they're going through the numbers, they're looking, this is very interesting. And they spend a lot of time refining the design, getting more efficiency out of it, and more efficiency out of it. And so it's been a fun venture. So we've gone through that whole process. So, it's like, we'd rather have somebody else tell the world, tell anybody else how we're doing than us, because it's just, it makes more sense. Anyway.
So what is the difference between your technology and the traditional wind turbine?
We pick up, in essence, we pick energy up around the outside, and the more common, the more contemporary, legacy type wind turbines pull it from the middle, and they concentrate it in a generator with gears, and they have to have gearboxes and all these things, and it converts it to the energy, and then and they have to be, because they become so large, which there's a lot of makes sense why they do it. There's that you can only get so much energy out of the wind. a wind mass has X amount of energy in it based on speed and density, that kind of thing. So they want to pick up as much of that as possible. But in the way it's being done, it's it's not completely efficient. They're not bad by any means, but they're not as efficient as we can obtain by the same air mass, basically. So we're able to, if you want to compare us together, we can pull a higher percentage of the energy out of the wind than that technology can. And there's a lot of benefits to us. I mean, back to them. It's like, because they're so large, you can, like in the United States, I'm not an expert by any means in their technology, but you'll see semis at passes with blades, that are huge. They can't make it over the pass. There's all kinds of problems about getting these parts out there. They tend to break down fairly often. You'll see a big wind turbine farm. You'll see half of them turning, half of them not, and it's just a general maintenance, that kind of thing. And so our version would have almost no maintenance. Everything's based on magnetic fields, so they don't really wear down. They don't wear out. An excessively hot situation, I suppose a magnetic field can lessen a little bit, but it's a very complex system, but we refined it to a very simple manufacturing process to build them. And through that process, we just, not we're out to compete with those guys, but we do, I think, a little better job on the efficiency level, definitely on the cost level, definitely on the, very, very low maintenance, that kind of thing. So.
What type of applications or uses would benefit from these turbines?
When we started with these, we were looking at honestly downtown in Manhattan, and being able to put a couple of wind turbines on the roof of a building. Because of our design, the big wind, or the wind turbines with the 3 blades spinning around, they could have, the wind around a building goes up its sides, all over the place. It's very turbulent, so it's hard to make a wind turbine work on top of a building. It's been tried. It hasn't been very successful. Our wind turbines, it concentrates the air through the front, so even air coming out the sides, on the back, around it, we're pretty good with that. So the turbulence is greatly diminished. So initially, we will be putting them on top of buildings, those kind of things, and it kind of grew from there. Industrial. Here in Texas, down in Texas, there's a large number of these wind turbines, the large wind turbines. When things froze up not too long ago, it caused a lot of chaos. And we're talking to a lot of folks in industry, the oil and gas, those kind of things, that would be potentially like to put our wind turbines on the roofs because as a backup system. But it can be more than that. And actually, our system works. It's almost like a solar cell field. We have our wind turbines. They keep batteries topped off. Those batteries go into the grid. It's a very smooth, very clean power. And so what we do is just keep those batteries charged all the time, and then that can run the operation. And then the big grid that becomes the backup instead of the main supplier of it. And like a lot of generators, if you're creating excessive amount of energy, you can put it back in to the main grid and profit from that. So industrial, and along with that, small, like example a housing development, 500-600 houses being built. Well, the developer for that can now work with us, and we create their own power company on site. So as they build houses and they sell off the houses and the properties, they would still own the power company. And whether they decide to sell that to the owners of the houses, whatever they want to do, and that can be done. And in a development, like say a 500 house development that's going to covering many, many acres, you could have several locations. Typically, we'd be ganging 3 of them together, and so they'd be 3 in one site. Take up the size of something very similar to like something similar to like a single wide trailer. That's about the ground space we need for these. So you put one in one area and one in another area, depending on the flow of the land and that kind of thing. And as that goes along, and then smaller versions, like some people have small buildings, and they like to, can we just put a small version on top of your on top of their building? Well, yeah, that's kind of what we're going for. And so they can be almost anywhere, but part of the good thing and the cost savings are that they're local. They can be right proximate to the need. They don't have to be miles away. Um, so
Well, so you kind of answered my next question around how many can you have in an area. Like you mentioned just a minute ago, how in a development of 500 homes, there could be 3 of these
yeah,
or so, depending on the requirements.
yeah, it'd be 3 per area.
Okay.
What we do is to be conservative. We're looking at if it's capable of putting out, say, 75,000 watts per hour. You end up with, okay, let's cut that in half, put 3 of those together, and then figure out what the wattage per house is going to be using, and that's divided out among those number of houses. And as they continue to build, we can always build another power station located. They had figured this out before they started building, but yeah, it's a very small footprint basically, and they're in ducts. It's basically a big duct. It's not dissimilar to what a jet engine might look like in essence. We take advantage of a lot of those technology advancements in jet engines, and we apply them to what we're doing here. But they are smaller. They can be painted like the sky. They can be painted, however you want. So they're not going to be so much in your face.
I love how this is innovative in the sense that it would be appealing to developers or building designers who would put these turbines on top of the roofs, and they could generate power for each floor or each individual floor. They become the utility, and they can charge that back to the tenants.
That's exactly right. And a big thing about the micro grids out is the idea of decoupling from the main power systems, and that protection, that safety, those kind of things. That if something was to go down, you have your own system. So this can outright decouple you. Especially if in a region like I'm having a conversation out in Hawaii right now, where they want to put a desalination plant on the coast, but there's no infrastructure to it. So basically, put a desalination plant with our wind turbines and the system, and they'd be able to run that without any kind of connection to anything else. So just those things, military applications. There's lots of applications available to us. So.
What about bird protection? And are they noisy? Like, what are your answers to those 2 questions?
Well, again, we actually take some of the technology used in jet engines, in that you have the parts counter rotate within the wind turbine. Mm-hmm. And they basically cancel out vibration. They cancel out most of the sound, those kind of things. And because of what we learned doing the propulsion, we're looking at doing a kind of a grid that would go in front of them, but yet take very little energy out of the wind to do that. And that would basically block any foul, anything from being able to enter them for the most part. I mean, if something really wanted to, they probably could, but it will definitely diminish that impact. And like example, in the United States, the EPA has now become more involved in the smaller, we're considering, at 100,000 watts, we're definitely a smaller type of wind turbine. They've never seen anybody like us, or not quite sure what to do with us, but we're much smaller, and the very, very little environmental impact, and those kind of things. And as we progress and end up with some kind of it would be like a hemispherical looking globe that fit in front of the wind turbine. Mm-hmm. They'd be transparent, but that would keep birds and that kind of thing from flying into it. So.
In this part of Canada, the east part, there's a lot of discussion about offshore wind and harnessing that power that comes off the Atlantic. Would these be offshore wind capable? Like, could they be modified for the environment here?
Yes, it does help the way they're built. Not that they have some amazing technology in these offshore systems. Again, because of ours being able to eliminate vibration and those kind of things, it would really help with the environment, with those mammals or they get used, sonar and that kind of thing to get around in the ocean. They're not going to be affected, or not really affected as much. Now, we're small, but we already in a design process to be able to retrofit the larger wind turbines with a number of ours. They kind of look like sunflowers at the end of the day. I'll share some pictures with you if you'd like to share with people. But with the idea of what does it look to retrofit, examples, some of these big wind turbines they're under leases. Those leases are running out. So there's property owners for these big things in their property. Is there a better way? What can they do with these now? And that's a possibility that we're moving into, retrofitting some of these. You lose some of the benefit because again, you're miles out from anything, but the structure's already there, the base is already there. Everything above the top of the base goes away, and then when we come in, and because very low maintenance, and there'd actually be multiples of them. So if something was to go wrong, you could remove one unit and keep the bulk of it going and replace that unit, for whatever reason. So,
what's next for Airborne?
As we evolve, we're excited. The industry is starting to learn about us more and more, about what we're doing and our technology. So our next phase is deployment. It is getting some prototypes out there, and then moving forward and with in the industry. Again, as one thing leads on the other. As the technology gets better and better with our wind turbines, we're in a relationship with Maya, and we're bettering. There's many smaller details. Like anything out there, our first one is going to be our worst one, but our worst one is pretty dang good. And then we just keep developing on that cycle. But as we learn from those wind turbines, it actually does help us back into propulsion. So we learn that way. But we also do other things. So our motor systems, if you want to call them, are kind of interesting. They operate a little bit differently, more like an electric jet engine is the way to put it. And so we're working on some air handlers for big mines, those kind of things. So everything from air handlers. We have some mines up in northern Idaho, and one of them is going to be using our wind turbines to power them. They're kind of out in the middle of nowhere, which is very typical. So that's just another use. So we have a relationship with those folks. So we're planning to get involved in, and right now we have all their wind testing systems up there, and so we'll replace those with some wind turbines to power their needs and that kind of thing. So definitely going that. It's kind of it's a really a good. It's not where I thought it would end up, at this point, but it's a very feel good thing. We're in Tanzania. Lots of villages, not a large infrastructure. They're building it out like crazy, but they could use our wind turbines in a lot of villages, those kind of things. So there's so many uses that could be done that are simply, islands in the South Pacific that have a need for energy. Right now, everything's brought in usually with diesel on ships, so very, very expensive. So we can help, work in all these different environments. And I really think it's going to be, not my words, but they're coming from our engineering departments and those kind of things outside of our company. They're thinking you're really going to change what this looks like in the world. So we're working on it, and we're excited about it.
I'm excited too. I can't wait to see how your technology evolves, and what the upcoming months and years look like for you. Thanks so much, Jesse, for joining me today and being on the Reimagined Energy Podcast.
Thank you so much. I really appreciate your time too.
Thank you for listening today. Give a listen to our other podcasts on our website, reimaginedenergy.com. The fine folks behind this podcast who sponsor us is the Smart Energy event, which is held annually in Halifax and in Vancouver. I'm your host, Maria McGowan. Bye for now.